Hi, everybody. I thought I would go and do a script showing the code for Lab 9 that you completed just on Sunday. And so here goes. Here's the lab. As you know, we're going to read in the data set. It's WNBA basketball players. We're going to prepare a report. We're going to have an introduction. We're going to have three visualizations, two tables with four regressions each. So pretty straightforward. Um, let's reduce this and go to R Studio then. So I copied and pasted this into R Studio. So um, we'll later, when we go to Markdown, we'll add an introduction and all the discussion. For now, we'll just focus on this. Now, um, the link here is to this link right here is to the definitions of the variables in the data set. So I'm going to copy this and go back over here and paste it in my uh, address and whoops, add an emoji and go to that. Here it is. Oh, sorry. I think it's searching for it rather than putting it in the address bar. I did the search. Yeah, here we go. So WNBA player name, height, weight, their year of the season, the team, age. Then we have a whole bunch of continuous variables. So these all look like continuous variables, the average, per game, the total number of minutes per game, and whether or not the player was a starter. So not a lot of factor variables. We could if you wanted to really shine, you could go by their name and try and determine their ethnicity, but that's usually pretty hard for American players. For other countries in the world, the name is a strong indicator of ethnicity, a strong correlate of ethnicity. Um, yeah, not the teams. Maybe you know something about the teams, so you can group them into two categories: bad team, good team. I guess that could be a way to turn a variable that has many categories into just two categories or three categories. Age, you could have, young players, mid players, and older players. Those are ways to create categories. So looking at this, we see there's a few things that you could do. So let's go back to R here, and we'll just load in our um, two library commands and read in the data set. And there it is, 146 observations, three variables. When I look here, row names obviously is not a variable I should have displayed. So the first thing I'll do is maybe do a data summary table. Got it on caps locks here. So data summary. And the syntax for data summary is data equals WNBA. Then I tell it the variables I want to display. Maybe I'll have it display all of the variables. And then I tell it the what I want, mean plus SD plus median plus N. And I think that should be enough to get the basic, no title. You can tidy it up looking at the textbook for, some things that maybe tidy it up. And now we see, now the bad thing about this table is it produced, the row names, which had no values, obviously. Um, so everything looks continuous. So not a lot of categorical variables or variables just taking on limited number of values. We could do the min and the max to see the age. Year seems to be all 2019, so that's not very interesting. The mean and the median are both 2019. We could do a table command just to check that. Table WNBA dollar sign. Well, let's do age while we're at it. So we see the ages range from 19 to 37. So we could definitely put them into three groups, one, two, three. Let's do that. So we'll make a little better. So we'll create a new variable, WNBA dollar sign age group. And we've done this many times in the lab, so you should totally know how to do this at this point. We'll use the if-else command. So this is just base R. Now we have our condition, NBA $age. If it's greater, if it's less than, let's say 25, then we'll make it be young. Then we can do a nested if else, um, WNBA $age is less than uh, 30, then they'll be middle, and otherwise they'll be old, right? So three categories. Notice that the if else says if they're less than 25, then they're young. The next category says, well, if, and because the condition here is else, so if they're not less than 25, but they are less than 30, then they're middle, and then everybody else is old. So if we run this, I misspelled WNBA, WNBA, WNBA. And now we can do the table command. I'll just copy it here for age group. Yeah, and we got middle, old, and young. And you know what we can also do is copy this just to verify. So I'll put the age first in the table command. So I can do a cross tab uh, by two ways, right? So uh, ages 21 through 24 are all categorized as young, 25, 26, 27, 28, 29 categorized as middle, and everybody over 30 or older is categorized as old. So that worked very nicely. Um, now that I have that, I can do a box plot. So ggplot, uh, I tell it the data equals WNBA. The aesthetic is going to be X. I'm going to make the age group be a factor variable. Where'd that go? Did I delete that? Oh, I should be putting this at the bottom. Sorry. So, so I'll have the age group as a factor variable, and then the Y I'll have um, average minutes average minutes played, and then I'll go plus histogram, not histogram, box plot. Going to do a side-by-side box plot, and let's see what this gets me. Yeah, well, we see that here's the distribution. You know, they're not in the order that I would have liked, young, middle, old. So you can think about how can I change the order around in the box plot? One way I could have done is by calling them one and two. Let's do it just with no, and then three is old. Notice what happens. Let's see if this works. Yeah, so now they're ordered because it orders alphabetically or numerically. So one, two, three, old. So we see that young players play fewer minutes than middle players. Old players play the most minutes, right? Why would you keep an older player if you weren't going to play them, I guess, is the idea here in the WNBA. Very good. So nice box plot. I could put this, remember, plus sign always has to be at the end. And let's do theme underscore classic. And run that. Now it looks a little better. And you know how to put the mean in there. The instructions are in chapter 2, I believe. Shows you how to put the mean in there. Also, this is the median, so you'd want the mean. So nice box plot. You could add a title and things to it. And now let's do a scatter plot. Most of you did the same scatter plot. So I'll just copy all this. So the aesthetic is going to be, let's have the average minutes played, and then Y is average points. which there we go. The pretty obvious. Geom point. Yeah, so pretty obvious. We can make size equals 0.75, color equals blue, color equals blue, and that has to be in quotes there. So all the syntax things, a little nice. Maybe make the size be 1.75. Yeah, that's decent. Boxplot could add the geom smooth method equals, let's get my regression line in there. Remember to add the plus sign then at the end. And now we have the smooth line. Since I don't know what the standard errors are of this prediction, I'll put SE equals false and maybe make the color of the best fit line red. Yeah, that's a perfectly decent. I should change the labels and I need a title, but pretty clearly the more minutes you played, the more points you score. So now we can move to the regression analysis. So I'll do R1 equals LM. And remember, my outcome variable is average points, I believe. So and then we'll have as explanatory variable. Where's the tilde? Tilde will have average minutes because obviously you score more points if you're there more minutes. So that's obviously sort of the variable of interest. And then we have data equals WNBA. And now what I'm going to do is I'm going to do the same thing, but with three subsets for each of the age groups. So that'll be my first one, 2, 3, 4. And instead of the full thing, I'll have subset. I could do it two ways, right? I could do the condition, but since I made the groups, it's easier to just make the groups. So age group tuple equals, and then I'll put that for the other three. It doesn't take too long. I have to, copy and paste the age groups here, but that's so it's too young, middle, and old. I'm very curious what this tells us. So then I gather the models into a list, R1, R2, R3, R4, and then we have a model summary of these model summary of the four models, and I'll put stars equals true. And the correct standard errors, variance covariance equals robust. So heteroscedasticity, robust standard errors, right? So let's go ahead and run these. Did something wrong here. Oh, I forgot to need two parentheses here to close the two parentheses that are open. Common syntax error, right? So here's my regression results going to appear in my window. Let's make this a little bigger. I forgot to limit the goodness of fit measure, so I got everything right. Um, the models fit right. Obviously, it's very strong relationship. The more minutes you play, the more points you score. So it's, R square is 0.8. 80% of the variation in points scored is just how much time you're playing, right? There's an omitted variable bias there, of course, because if you are in a lot of time and you don't score points, then they don't put you back in again. So your ability is sort of the omitted variable in this. If you took a random player and played them a lot, they wouldn't score a lot of points. So it's a good example of omitted variable bias here that we would think our simple causal model of average minutes played is you put a defensive player in. And they're not going to score a lot of points just because they're playing more minutes now. Uh, so they notice that the coefficients barely change by age group. So it's zero point 0.4 roughly for all three of the age groups. We have the number of observations. Here's the total. then for each of the age groups. Obviously, I should label these all young, middle, old. I have a title, limit the goodness of fit. That'll be a very nice um, regret table of regression results, right? And then I can, now the nice thing about this is I can copy this all over again. And instead, I'll put in the interaction of average minutes played with age group. And I'm curious how R is going to do this because age group is not a factor variable. So let's see what it does. Didn't give me an error. And when I display the results, yeah, look, it nicely created the two of the interactions, right? It can't create the third because then you'd have perfect multicollinearity. So it's middle and the old. And you notice that the interaction term is not statistically significant, suggesting there's no difference in the relationship. Sorry, it's down here, is the interaction term. There's no difference in the relationship between average minutes played and points by the three different age groups. I could also run this as a continuous variable, right? So we'll have now an interaction term of average minutes played times, I guess it was just age, right? And not have the subset here, WNBA. And let's run that. So now my second regression is going to have the interaction of the two continuous variables, not statistically significant. Interpreting that's a little trickier, right? So I'll leave that for you to interpret. But pretty good. Notice it included the underlying variable age also. So I didn't have to include that as a separate variable. And then let's go with average minutes played times starter, I guess. Why not? Um, and then let's do, so need the plus sign here. And then let's do, not too much else we can do, right? Because we don't have any other variables. Height, weight, I know because you explored it that height and weight didn't seem to be significant. Let's put games played here. So games underscore played. Yeah, now we got some nice interaction terms. So one, two, three, four, and now we have our regression results. We can do more, obviously, but let's see. Is it displayed yet? Not yet. Oh, yeah, it did. Yeah, nothing. None of the interaction terms are significant. We have 146 in each. So, kind of interesting. Didn't play out anything super interesting, but there we go. I'm not going to do the markdown because everybody seems to do that pretty well. I'm going to delete this. And now you have some code that you can use. My data summary, I would now that I've seen what variables I did in my analysis, now I would copy this and instead of having all the variables, I would delete that and I would put the variables that I just used in the regression and the tables and have all of them be in the table of summary statistics. So that'll be better. There's no reason to have a table of summary statistics of variables that are not used in the analysis.